Hi, welcome all of you in this session where we are going to talk about HDFS, which stands for Hadoop Distributed File System. So we are going to talk about what exactly is HDFS and what is the design of HDFS, what is the motivation of using HDFS, how is data stored in HDFS, and what are the considerations you have to make, like when should you be using HDFS, when you should not be using HDFS. So let's get started. We are going to talk about the important design of HDFS. And before that, it is important to understand like what exactly is HDFS and its characteristics. If we talk about big data, then there are some important challenges in big data. And these important challenges include the velocity, the volume, and the variety. So we have to tackle these all three challenges. Now, what exactly are they? So it's important to understand some important characteristics about these challenges. The first is the velocity, which means the rate of data ingestion. You are receiving data and you are receiving data from multiple sources, not one but many. And you have to design some framework which has to take care of these large data ingestion. Volume, needless to say, the amount of data, the size of data, it is growing every day. So having terabytes of data or petabytes of data is, it's very common these days. And if we talk about variety, we have got lots of different formats. We can handle doc file, we have to handle PDF file, we have to handle JSON file, we have to handle XML files, and we might also require some data from RDBMS. So if we categorize the data, it can be under kind of unstructured, which does not have any schema like doc or PDF or text files. It could be semi-structured, which have some sort of schema, but not necessarily force them on some basis of constraints. And there are third category of data, which is a structured, like which we take from RDBMS, which have fixed schema, which have got fixed structure, which have got some constraints over the data. So considering the velocity, volume, and variety of the data, we need to store the data which has got the challenges of velocity, volume, and variety into some persistent store. Now, let's go to understand what is the motivation behind using HDFS. The first motivation behind using HDFS is the challenges of big data. We have to understand what are the different challenges. The second motivation is we should have a design which is cost effective. Obviously, there are two ways to handle situations of big data. One is a scaling up, one is a scaling out. In a scaling up, you increase the configuration of a single machine, but in a scaling out, you depend on multiple machines and you share the load across the multiple machines. So we have to design something which is cost effective. Moreover, we must be tolerant to the failure. That is, if we are using multiple machines, then even if one machine goes down, we should not be facing any downtime. We should get the data from some other machine. Okay, so what happens is, considering these three challenges, HDFS has been designed, which essentially stands for Hadoop Distributed File System. So let us try to understand what exactly it means. What is a file system? I'm going to show you something. Suppose if I go to my machine, if I go somewhere and I create a file, okay? Let's take a very simple example. So I'm going to write this is a file, okay, and I'm going to save it. So once I go to save this, it does not bother me like where should I be saving this. I can save it anywhere. Okay. Once I save the file to my machine, what happens is if my file has got a rotating type hard disk, so my hard disk may look like this. This is my hard disk, and this is certainly the uh, support on which it spins. So this is how it happens. My hard disk keeps on rotating, and this hard disk has got some sectors, then it has got some blocks where the data is stored. So I need not to worry where exactly my data is stored on the hard disk. A hard disk may look like this. This could be, it contains lots of sectors. So it may look like this. So yes. So these are the different blocks of the hard disk. So you should be able to understand like how these blocks store the data. Every block is of some size, very small size, maybe in bytes or kilobytes. That depends on the on the hardware level. Now I saved a file. The file may contain say 10 blocks. So one block can be here and the other block can be here. Every block is of same size. So it could be like that. And one block can be here. So it's not sure that every block will be contiguous in nature because files keep on getting added, files keep on getting deleted, and as a result, there could be some kind of fragmentation in the hard disk. That is, few blocks may be empty and files may not get kind of contiguous storage. So that is there. Basically, the point I would like to make here is this is the duty of file system. So where the actual, suppose you save a file at certain location like C, then you go to documents and then you say file.txt. But this file is saved in terms of blocks on the hard disk. So who maintains this mapping? It is done by the file system. So you get an interface where you can make changes to the file or create the file, and internally everything is handled by the file system, like where the changes have to be reflected on the hard disk. And if we talk about the distributed file system, it's like it is not local to a single machine. There could be multiple machines, and we are going to take advantage of multiple machines for distributed storage. Now we are in a good situation to talk about HDFS, and before we proceed, let's try to see something. Yeah, let us try to take a look at this chart. What does this mean? If you see in the year 1990, the data size that could have been stored by a single disk was little close to 1.5 gigabytes, that is 1400 megabytes. And the transfer speed was 4.5 megabytes per second. The transfer speed means the time taken to bring data from your hard disk to the RAM, because unless you bring the data to the RAM, you can't do the processing. So if you divide the data size by transfer speed, it will come close to 5 minutes. It means in 5 minutes, you are able to completely scan the hard disk. But now in 2010, a typical storage is 1 terabyte and transfer speed is also increased. It is 100 Mbps, but it will take 3 hours to completely scan a hard disk. Why? Because the data size has increased, transfer speed has also increased, but not in the same proportion. As a result, it becomes very slow for operations to get executed. And if we talk about big data, where we are talking about a large volume of data, one point we should understand is The processes are input output bound. That is, more of the time is consumed to take data from hard disk or to write to hard disk. Processing of data takes very less time as compared to the input output of data. But what you can do, just imagine a situation if you are not using one machine, rather you depend on hundreds of machines. So you divide the data across hundreds of machines. Like if you have got 1 terabyte of data, you divide the data equally across hundreds of machines. And if you try to scan in parallel, that every machine is scanning the data contained by that machine, in that situation, the 1 terabyte of data with the help of 100 drives, every drive having a size or a transfer speed of 100 Mbps, you can read 1 terabyte in 2 minutes. This is the real advantage of distributed processing. Like, you do not depend on a single machine, but you depend on multiple machines for the storage, for the processing, both. One important distinction I would like to make here is, let's talk about more about HDFS. And this is an important concept to understand. We talked about multiple machines. Suppose we are having few machines in our, this is called as cluster. So we are having some number of machines. The cluster can have hundreds of machines or it can have thousands of machines. So that is perfectly fine. So in case we are having, say, six machines are there, and assume that I have got a file. This is my file, and what I'm going to do is I'll divide my files into some chunks, some blocks, and in Hadoop parlance it is called as blocks. So this is my file, and I divide the, suppose the file name of file is F1, this is block B1, this is block B2, and so on. Assume that the file is made up of 5 blocks. What happens is every block will be stored on the machines, but before we talk about the storage, let us talk one important activity. Every machine has got its storage in the form of some file system. So that's there with every machine. Every machine, suppose every machine has got a storage of 1 terabyte or 2 terabytes, some storage capacity is there. And what happens is some portion of the storage is dedicated for the machine and the remaining portion is dedicated for HDFS, that is Hadoop Distributed File System, on every machine. And it is the duty of the administrator to make such a distinction, like what portion will be there which is local to the machine and what portion is there which is dedicated to the HDFS. It will depend on the cluster, it will depend on the what are the purpose which are served by the machine. So it could be like if the machine has got 1 terabyte of storage, it could have, say, 800 MB for HDFS, and it can have the remaining data for the local. That is little more than 200, that is 224 megabytes for local. So it could be like that. This is one possible situation, but it depends totally on the administrator, depending upon the need of the cluster and depending upon the need to store data. What happens is, now the file has got blocks, so every block will be moved to some machine. It could happen like block 1 can go here, it can happen like block 2 can go here, and similarly block 3 can go here. So file will be divided into blocks and every block will be stored on the HDFS, that is Hadoop Distributed File System. And in order to, suppose what happens is, if this particular machine fails, then the block contained by this machine will not be accessible. As a result, one block is not stored at one, but by default at 3 different locations. So your block 1 can be here, block 1 can be here, and block 1 can be here as well. So every block will be at 3 different locations, which is called as replication factor. And these blocks will be there in the HDFS. Similarly, your block 2, it could be possible like block 2 is here. Block 2 can be here as well because of replication. Block 2 can be here as well. So it is a possibility. So every block will be at 3 different locations. Now, let us go and talk a little more about HDFS. And as of now, you would have seen 2 important configurations. One is the block size, what exactly is the size of blocks, and one is the replication factor. So replication factor is just to increase the availability. It is by default equal to 3, and the block size is by default equal to 128 megabytes. That is, if you have a file of 1 gigabytes, that will be composed of 8 blocks in the HDFS. So this is how the block size and replication factor is governed. In case you have got multiple files or multiple machines and every machine is storing some data in the HDFS, we have seen that. So assume that every machine has got its storage, and some portion of the storage is used for HDFS. Assume the color in the blue are the color, or in the green, the color in the blocks in the green are for HDFS. So these are the segments reserved for HDFS, and the segment in the brown, they are for local file system. It could be a possibility. Okay, so there is a machine in the Hadoop cluster. This machine is responsible to keep a track of the HDFS of every machine. Like it keeps a track of what is the content of HDFS of this machine, what is the content of HDFS of this machine, and what is the content of HDFS of this machine. This machine has a special name called as name node. Instead, name node is a process. Name node is a Java process that keeps a track of HDFS. So which HDFS is overloaded, which is not. So in this way, it could be a possibility like every machine has got a capacity of 1 terabyte. But your HDFS, if every machine gives 80% of their storage to the HDFS, then you can consider 80% of 3 terabytes, which is equal to 2.4 terabytes. So your HDFS has got this much capacity. So the capacity of HDFS is much more than the capacity of a single machine. And one important point here I would like to make is on every machine there is again a process called as data node which keeps on running. So data node reports to the name node. On a frequent basis, data node sends a signal to the name node. Data node also sends the block reports, like what are the blocks contained by the HDFS of that particular data node. This signal has got a special name called as heartbeat. If the name node does not receive this heartbeat for a longer period of time, then it will consider that machine to be failed. And in this way, name node keeps a track of which machines are active and which machines are not. This heartbeat is sent on every 3 seconds. This is the default configuration. You can obviously control that, but this is how it behaves by default. So we have talked about name node, we have talked about data node. Name node is the master process, data node is the slave process. Data node has got no idea about the local file system, about the local content. Data node only focuses on the HDFS content of every machine. Name node gathers all the signals, all the heartbeats, all the block reports from data nodes and maintains that report in its memory. Let's try to revise what are the things we have learned. So we started from what exactly is the design of HDFS. So let's have a very quick revision. So the HDFS is designed to handle very large amount of files such that files have got streaming data access. That is, you write the file once and you read that multiple number of times. And HDFS is built on commodity hardware. That is, it does not require machines to be high end. Yes, name node requires to be of better quality, but the data nodes, they can be on any machine, any commodity hardware. Okay, so going further, we also talked about in this particular session, uh, like why do we require scaling out, or why do we require distributed architecture? And one important thing I would like to make here is the HDFS blocks. How are they different from the blocks of local file systems? So this is a typical rotating type hard disk where these are the tracks, the circular concentric circles, and there are lots of sectors, and again its data is written to these blocks, which are very small. This block is of the size of 512 bytes. It could be in KB also depending upon hardware, but they are very small. And then there is a head which keeps on reading and writing the data, and this hard disk keeps on rotating. Okay, let's go further. What happens in HDFS is it is different from the local file system. Why? If you have a file in the local file system, then the blocks of the file can be scattered. They may not be contiguous as we discussed. But one block of HDFS will be as contiguous as possible. So that's a very strong difference between the blocks of the local file system and blocks of the HDFS file. Why? Because if the blocks are contiguous and if this particular hard disk rotates, then in a single rotation, you are able to read all those data. So that increases your efficiency by decreasing the time taken to read the data. Okay. So we have got a graphical representation to show you like how the blocks are stored. Suppose we are having a file, some data is there like employee name, experience, location, some data is there. The data we need not to worry. The size of the file is 260 megabytes. If the block size is 120 megabytes, it will be decomposed into 3 blocks, where 2 blocks will be 128 MB and 1 block will be of 4 megabytes. So these are the 3 blocks of the file. And ultimately, there are name node. We have not talked about secondary name node, that is not required here, but data node is something which is required. So name node contains the details, the metadata of the Hadoop file system. It contains the mapping, like which block is of which file is maintained by which data node. And the data node contains the actual block, and they send the signals to the name node periodically to verify whether they are active or not. So job tracker and task tracker are also there. They are related to MapReduce. We are not going to talk them now. So this is how suppose there are 5 machines. So one block, that is F1 B1, means the first block of the first file, it will be stored at 3 different machines because the default replication factor is 3. Similarly, your second block of the same file, third block, and all the other blocks of the file will be stored on multiple machines. And there is a service called as name node, which keeps a track of the heartbeats, which keeps a track of the block mapping of every data node. So there is a question like why HDFS blocks are collection of contiguous blocks on hard disk. We discussed what could be a possible situation? To reduce the seek times, or to reduce data, to read data in less rotations of hard disk, or contiguous blocks account for a storage of different varieties of data, or a large number of users can access data. So if you have gone through this particular lesson, you should be able to understand the correct options are 1 and 2, to reduce seek times and to read data in less rotations of the hard disk. So this was all about the SDFS, the design of SDFS. I believe it should be clear as of now, like what exactly is SDFS, how different it is from local file system, how is the design of SDFS related to the solving of challenges of big data. There are many more things which will come up, like we will talk about the SDFS commands, like what are the different commands which we can operate with the files and directories present in the SDFS. Those things will come up in the upcoming sessions. And in case you want more detail on this particular segment, you can certainly visit to the blog of Acadgild to get more content. So this is the blog which you can certainly access and get many information, valuable information, and on different diverse technologies, including big data, Android, AngularJS, and many more. So that was all in the session. Have a good day.